So this is my physics project, and if you are not able to tell, it's about building a functioning crane. So my original goal for this project was to build a functioning crane that has some kind of advantage to it. So before I talk about the design that I made, let's talk about the actual materials that we were using. Now, first material was the 20 milliliters syringe, and second, and we also been using this tube. To, we have also uh, 60 milliliters syringe, and as you can see, the base material for this crane is cardboard. So, and for the bolts that we're using, like nails, I using marshmallow sticks or skewers. And if you look here closely, there is a zip tie. This is what I'm using to mount the syringe. Now, the reason why I'm using a zip tie instead of gluing it is because, as you can see, sometimes the liquid just runs out sometimes. So if I want to refill it, I want to like take it apart. So I could just do this, and I could like take this apart. So that's why I'm using that's why I'm using a zip tie instead of gluing it, because I want to actually like take it apart if it's like something wrong with it or anything with the syringe. So that's why I'm using a zip tie. Now, as you could tell, I have also been using uh, hot glue sticks and a hot glue gun. You could even see it right here. This is the hot glue gun that I've been using, and this is the glue right here. I've been sticking these, and you can see some glue here, some glue here, some glue that reinforces the crane, like right here, and we also have right here. So I've been using also glue sticks and hot glue gun. Now we have been going over the materials. Now let's get into the design. The first part of the design of this crane is the base, which is this shoebox that I have here. This base has two functions. One that is one of the main function of this base is to give the crane some weight, so it can hold the object. So when it's carrying an object right here, it doesn't just fall off right like this. So it needs to have some weight, and that's the main function of the base. But you can also look that it also gives the crane some height. Now, the height of the crane should be really just you should balance it out between the stand and the base and the arm. So it's really just how you measured it. So I just eyeballed it, and it's really, you could eyeball it too. You don't have to take exact measurements, especially because this is a home experiment. This isn't some serious experiment. Now, the second part of this design is this stand. This stand is like what is connecting the arm to the base. So it has a very important role in this, in the design of the crane. So now the function of the arm, the main function is to connect the arm with the base. So it gives the whole crane some weight so it can carry objects. But it also gives but what this stand has to have is it has to be like hard and reinforced, because if the stand falls apart, then the crane cannot carry any objects, because if this falls apart, then you cannot carry objects. It's that simple. So this has to be hard and sturdy, and you don't want it to fall apart. And the main function of it, of course, to connect the arm with the base. Now the arm, the function of the arm is to pull the objects up and down. Now this can be happened when you, by the final mechanism, the piston. The piston's role is to when I push this syringe, as you can see, it's pushing the water in here, which causes this syringe to extend, which causes the arm to go up. And if I put an object here, this object will be lifted. And so you could see that the arm and the pistons are kind of one part, but they're actually not. They're different parts that I made for the design, and they kind of synergize with each other, which make them have this role in carrying the objects themselves. Now, I've talked about like the design of the crane, but what is the advantage of this crane? Like, why not make a different crane? Like, why would you use this crane over another crane? And this goes over why we're using a smaller syringe to push water into a bigger syringe. And now, if you want to really understand it, this is how I understand it. If you could see this 60 milliliters syringe, if you want to push 20 milliliters from this syringe, you have to give this syringe more force, but it will travel less distance. While if you're going to be using the smaller syringe like this one's going to be traveling greater distance, but you need just a small amount of force to get 20 milliliters. So basically, if you ignore the distance, you're basically multiplying forces. And if you want to know how much you're multiplying the force, look at how much the volume of the syringes are. This is 20 milliliters and this is 60 milliliters. So if you divide the bigger one by the smaller one, it's like 60 divided by 20, which is giving 3. So our multiplier is 3. Now, can we improve the design of this crane? Now, the design of the crane, of course, there's a lot of improvements that you can do, which, yes. But when it comes to the materials, which is what I want to improve on this crane, the base material, which is cardboard, could be improved to wood, which is a really good material because it's really sturdy and just really good for homemade experiments and homemade stuff like this. And also cardboard, if you want to make this crane, do not make it out of cardboard. I made a big mistake, and I didn't have any wood in the house, so I couldn't make one out of wood. But the reason why you don't want to use cardboard is because first, it's not really the sturdiest material, so you cannot actually carry a lot of heavy objects. But also, cardboard, when it gets splashed with water, it becomes as weak as paper. So if this leaks somehow and it goes to the stand is gonna collapse, okay? So you don't want that to happen. Now we talked about and also these marshmallow sticks could be improved into nails, and this zip tie could be improved to a bolt that will be hooked here and will rotate the syringe up and down, which pushes this up and down.